streaming.
Excellent.
Welcome to MySec Lansing. As far as announcement, I don't really think I have any major announcements unless anybody's got anything else going on in the Lansing area. All right, with that, I guess we get started. Hand it over.
Social at the end of the month, right?
Yes, we have the social at the end of the month. Last Wednesday of the month, whatever date that is.
True story. It
Yes.
may or may not be the 28th.
It's the 28th, yes.
Yeah.
All right.
Sounds legit.
Yes. All right, with that, I'll hand it over to Brandon and to do an intro on Docker.
Yep. Golf clap.
Yeah.
So, well, thank you. So this is going to be an interactive workshop on the intro to Docker Engine. And I have a VM set up that we already got people here in the room working on. And those who might be streaming this right now, we should have a link over in the chat where you can go and grab the VM. And it'll download it from OneDrive. And there's going to be a little bit of configuration to go through at the beginning of it, which I'm going to go through real fast. We'll do a couple of slides for a few minutes, just going over Docker and some of the containers in general. I won't torture you too much with too many slides, and then we're just going to be going back and forth of working inside the terminal, working on our laptops, and then at the end, if we have time, we'll look at a couple of different InfoSec projects and how Docker is used inside of them. So first off, let's talk about the VM prep. So inside of the OneDrive link that's provided, there is a URL that is included there that leads us over to this secret gist that is our lab manual, if you will, for this entire class. And so at the very beginning of it, we're going to have booting up the VM. So the VM is a OVF file, and it looks like, I'll bring it up here on the screen here. Looks like these series of files. Down here is the workshop manual that will get us over to that page I had over there. So you'll just double click this option for your hypervisor to import it. Make sure you select the location, select import. I've already done this, so I won't wait the minute or two that it takes. Two very important things to do once it's imported. Inside of your hypervisor, and this is VMware Workstation, we want to make sure that you set your networking config over to NAT type, which is usually under this network adapter section. And then if your hypervisor has some type of time sync, you'll want to make sure you turn it on. Synchronize guest time with the host. You want to make sure that the VM thinks it's the right time, so when it's generating its keys that we're going to be using a little bit later, it works properly. So for those here in the room, you guys are all set up, all ready to go? No, just like every workshop, there's always a little bit of time right at the beginning where you have to get set up and get all the troubleshooting out of the way. So hopefully everything else will go swimmingly, right? All right, well, let's get started with a little bit of PowerPoint death right in the beginning. So this is, as I said before, Intro to Docker Engine workshop. And my name is Brandon Hladysh, and I go by Pi Security on Slack and on Twitter. I'm not on either one of those very often, but it seems very accustomed for us to share those type of handles. So we've already covered the workstation prep, so I'll leave this up here for any type of recording if you need to come back to it. Probably should scratch this out saying, please don't use VirtualBox. It might not work as well. Go get VMware Player. All right, so talk about our agenda. So first we're going to go do an overview of containers. We're going to dig into the workshop itself. Then we're going to talk about Docker files, which is really the backbone of using the Docker engine. Then we're going to get into building something in the cloud using Docker Machine. And I've included this picture over here on the left of containers because Docker officially uses the container image, if you will, of a shipping container to describe what the company is. And I really think that analogy just works really well. Everything that you need to run an application in any type of environment is crammed into that shipping container, and then no matter if it's on a train, on a boat, or on a plane, it's going to get to its destination, and when they unpack it, everything will be there. So that same concept works with their environment. So the who am I slide, I'm Brandon. I work in a DFIR job, but really I'm just excited about Docker because I've been working with it for a couple of years now, and I started off with actually a workshop very similar to the one I'm giving here, where it was maybe a few years old, and I just went to a class on it, and it just really changed a lot for me because sometimes I want to try something new when it comes to a piece of software. And when I do that, I needed it to work, and I don't want to put a lot of effort into engineering it. Me personally, in a DFIR job, I don't have as much time building an environment as I need to really get information out of it. And this really works really well for me. I want to try things out without being committed to it. So originally Docker started as a platform only on Linux, and it has since been expanded to Windows and Mac OS. But before those days, whenever I would want to try something new, it felt like I was deploying a new version of Ubuntu. And then I would spend time installing libraries, running apt-get commands, and I didn't really know what I was doing, I would say. And it just seemed like that box was now committed for that purpose. And I wanted to use software without dedicating a box to it. All right, so let's talk about Docker containers. This is straight from their website. They describe themselves as a standard unit of software. It is flexible, lightweight, interchangeable, portable, scalable, and stackable, all crammed together in one little aspect of it. But I think the most important point when we look at it from an InfoSpec perspective is that it's disposable. A container is designed to have everything you need to run an application, but then that container doesn't need to exist past its initial execution. And it really forces you to think about things when designing applications and to run inside of Docker. So when we say that it's flexible, we've already covered that it can run in a lot of different locations. You have your container already set up with all of the libraries, all of the different executables that you need, and all the resource files to execute in another place in the environment. It's lightweight because it's not a full operating system like a VM file is, like we've been trying to use. That was about 800 megabytes. You can have a full application running in just as few as a couple megabytes. Interchangeable between different versions of Linux. Windows and Linux containers aren't necessarily interchangeable on their own. You have Windows containers that run on Windows, Linux ones that run on Linux platform. We'll have a diagram in a second that really explains that. And then portable, scalable, and stackable. The idea is that you design a container so you can you put all the effort into building one of it, and then you can times it by 100 and scale it horizontally across your network. And I really like the fact of being disposable. So compared to other container technologies, Docker Engine is specifically focused on deploying applications. So when we look at the differences between a containerized application and maybe something like LXD, which is focused on containerizing Linux operating systems, our Docker host will share resources from the underlying OS. So here we have at the very bottom on the left, you have your infrastructure, then you have your host operating system. In our workshop now, this is the Ubuntu image that you've placed into your system. And on top of that, we're going to install the Docker engine. So each application is going to run in a separate space, isolated from each other application, but they are going to share resources from the underlying host. And unlike virtual machine technology where you have your hypervisor and you have to install your guest operating system for each single application, you're saving not only processing power, but also disk space as well. And again, the fact that it's disposable makes it almost a very different paradigm shift from traditional virtual machines. Probably the first question that most people get asked about Docker is if they are meant to replace VMs. And they're really not. They're really designed to complement that type of technology because you could still have a VM running Docker Engine and still have the stack on the left deployed on the stack on the right. And it makes sense to be able to make your environment very elastic, that you need more virtual machines perhaps across multiple data centers. but you don't want to worry about the application itself. So you can even intermingle the two. And in fact, that's exactly what we're going to be doing with this workshop, Docker in a virtual machine. All right, so disposable nature. This was the hardest part for myself to wrap my head around how Docker works. So everything is designed to be ephemeral, can be destroyed and rebuilt with absolute minimum setup and configuration, because every new container is based off of an image. So in this diagram here on the right, we have like 4 of the shipping containers up at the top. So those are all of our containers. And then we have 4 layers below it. And those are what is going to be built off of our image. In this screen right here, it's Ubuntu 15.04, taken from Docker's website. But the idea is that every time we deploy a container, it's not copying this entire stack of the Ubuntu image. It's installing a very thin read-write layer that's going at the very top of that image, or top of that container. And whenever that container is going to interact with something else in the environment, it's going to read and write from that little diff, if you will, and still reach down to the rest of the image if it needs any other resources from it. So that means you only have to keep track of stuff in the writable layer. Now, when I said it's designed to be destroyed, so if your read-writable layer is containing information about your image, like let's say this is a Ubuntu image that you're running, and you have a website installed on it. Websites need to have resource files on it. You would build that into your image. However, websites tend to write log files, and that's something that you need to have maintained when the container runs. So you have to think about your application components from your application data separately. And when you're first running your Docker container, you want to make sure that you're already accounting for those components there. And then the last aspect of it is they're not managed like virtual machines. So if you ever need to interact with the container, you'll interact with it from the host operating system that's running the Docker engine. You're not going to secure shell into it. Perhaps if you're actually looking to do that type of interaction with your container, you might have taken a wrong approach with it. And we're kind of going to get into that in just a second. All right, it's workshop time. So I'd never actually updated this bit.ly link, but inside of the recording should have that information. And we're going to go ahead and switch over to our VM and hopefully everything else that will show up here in just a second. Okay. All right, so the first thing we're going to do after we shell into our container is we're going to want to sudo to root. Everything we're going to do in this workshop is going to be done as root. It's probably just easiest for it to be done this way. You don't need to be root to run Docker or the Docker engine. Of course, you need to be to install it. There's a specific group you can be added to be able to do that. So the first thing we're going to do is we're going to cover the different ways in which you can do installation. So we're going to cheat, and we're going to do the quickest image install just to make sure that we're not risking any bandwidth or having any issues running the Docker engine. So the absolute preferred way to do it is by going and getting the official package from the Docker repositories. And they include a nice little series of commands that allow you to get their GPG key, you'll verify their key, and then add the Docker repository to Ubuntu. And for those who are streaming it, if you want to take that approach to it, that can work really well. It's about 199 megabytes, so that's why we're going to not try to do it here. So we're not all doing that at once. Now, the absolute laziest way to do it is actually a curl command. So Docker git docker.com is a shell script that you can, well, if you trust it enough, you can just write this out to a file with curl and then run it, and it will handle all the setup for you. So they recommend that you do this for test systems, but they don't recommend you do this in production. So let's go ahead and get started with installation with Debian packages. So everybody sudo to root, and we're going to go inside of root's resource files. And inside this location, we have 3 Debian files, which are all the packages that you normally get with it, or that you would download if you were doing the repo command, and then also one of the dependencies for it. So we're going to install it with dpkg I, and we're just going to do star Debian. If you're coming from the image, it's going to install in the right order. Am I generating too much noise playing with this thing? No? Okay.
No, I think you're good.
All right. You guys good in the back of the room?
I downloaded VMware Player.
Oh, okay. Oh, all right. So it's confirmed VMware Player on Windows works great. All right. So now the first thing we want to check after we get it installed is we want to make sure that the Docker daemon is running. So with Windows, it'll be service Docker status. And all we're looking for is this green box right here at the top, just telling us that it's active and running. And well, green would be a good sign right here. All right, so moving on to the next section of it. The first thing, Docker has like a very basic testing container that will download and run right here. So it's going to be docker run it hello world. So make sure you're doing the dash in the hello world, and we're going to break down that command in just a little bit. But if you don't have the container already installed, the first thing that Docker will do is it will go and download it from the master repositories. It's referred to as the library, and this is really going to be some of the coolest stuff that we're going to end up doing with Docker. So if it all goes successful, you should get this message back from the screen saying that this appears that your installation is working properly. Good? Good? Okay. All right, so let's go ahead and take a look at some of our options that we have available with Docker. Okay, so Docker, as it says right here, a self-sufficient runtime for containers. This has so many different commands and subcommands inside of it. So I'm not going to go through every single one right here at the top. I just want to point out a couple of groupings, and then as we run into them, we're going to just see how they work and break them down. So newer versions of Docker included a series of configuration management commands. And they're used to manage different terminology to go along with it, such as the configs, the containers, the images. We're going to touch through a couple of these, but sometimes there's a command under this management section that's actually the same as one that doesn't involve the management section. And you'll see that if we run like the same command 2 different ways, and we'll see the help for it, it's actually the exact same command. But the ones that most guides that you'll see on Stack Overflow, or even older Docker documentation, perhaps some of the books, will have these commands written at the bottom. And they don't distinguish between the different subcomponents of Docker all that well. So it was almost designed as if you are on a normal bash prompt, like you want to copy something. So the command for Docker is docker cp. And that worked to a certain extent, and a lot of people still use that, and we're actually going to use it in our setup. But keep in mind that all these commands down here at the bottom, they go into different sections of the Docker engine. So we'll have a series for images, we'll have a series to run containers, kill, pull logs, port commands, push. But rather than getting too inundated with these, let's go ahead and step onto the images first. Basic execution. So we're going to run a CentOS environment. So for those here in the room, have a slightly different command than I want you to run. So docker pull. Okay, I'd like you to run this command right here. For those on the stream, you can run it exactly as it is seen right here in the lab manual. So what this is going to do is it's going to work like Git, and it's going to pull a copy of the container already in the repository. The version that is down here will pull it from the master repositories out on the internet managed by Docker. This one's going to pull it from my laptop right here. That's the only difference. And I'll show you how to verify it. When we do this with CentOS, we can run the bash command. And we're going to actually get a session over here in our environment. So starting off with Docker, run it, CentOS, bash. All right. So since the next thing it's going to take a little bit of time, let's go ahead and get the next thing on the way. This thing started, and then it should stop the rest of the downloads. Maybe. All right, so what we're going to be doing is we're going to be installing Apache into our container. And it's only 31 megabytes, but I don't think that matters to the Wi-Fi here. And we'll let this go. You're good?
It was pretty fast.
Okay.
Even though it went to the UM Flint mirror instead of the MSU mirror.
Mine went to Central Michigan, and they didn't have any of it. Okay. All right, that's not going to work. Okay, so now we're running Apache inside of our CentOS container. And let's start off by actually executing Apache. So that's going to just be HTTPD. And when we run this command, we can then do a ps aux, and we see that Apache is running. Now, there's only a handful of processes running in this. Remember, our host has a whole bunch more other processes on it, but our container is isolated to just the processes that it executed. And let's go ahead and test our website. So we're going to do a curl, and we're going to connect to localhost, and it's Apache test. All right, so I wanted to highlight one thing here that when we're running this. So Apache test doesn't really exist on this website. That's fine, but I wanted to show this error code right here. The server response is of Apache 2.4. It's running on CentOS. So to show the different delineation between the container and then what's running as the host operating system. All right, so let's go ahead and exit the container. So you type the word exit, and we're back to our Ubuntu prompt. So to see the containers that you are running, you use docker ps. And this shows that we have currently no containers running. Now let's go ahead and go back into that environment. So we're going to run the same command as before, docker run it CentOS bash. Now, when we run ps aux, we are not running Apache any longer. And if we tried to run HTTPD, the command's not found. All right, let's back out of this with exit, and let's kind of explain what's going on here. All right, so when we ran the first docker run it command, we told it to generate a brand new container off of CentOS, and we installed Apache inside of it. When we exited out, that container was turned off. Now that we ran that again, it now made a brand new container running CentOS. Apache is not installed in there, and so that explains why we doesn't have that command. So if we ran docker ps again, we see that we have no containers running. Docker ps-a shows all containers that have been run on this host. So we have two CentOS containers here, and when you don't name a container, it gives you a randomly generated container name, which I don't actually know where they pull them from, but sometimes they're hilarious. So for example, my container called Compassionate Heisenberg was one that was generated 3 minutes ago. And if I want...
Names of DoD classified operations.
Yeah, it sounds like that. It's classified operations. Whereas Pensive Lamport was the one that we executed the second time, and it exited 32 seconds ago. All right, so let's make that work again. So let's go back into that first container. So we're going to do docker start I for attached to standard in, and then the name of the container. This is going to be different for everybody. There's tab autocomplete too, so you don't have to type out the whole thing. All right, so now we're back into that original container. If we do a ps aux, we see that Apache is not running. We can execute it again with Apache httpd, and we're back to our little curl test that we can run as well. So curl local host Apache test. Okay. So now we're back into that container. All right. Let's go over a really important tip. Well, I can pause here for a second. Are we good to move on? Good? Okay. So let's say that you wanted to go back into that container, but you absolutely forgot the I command. You just kind of forgot about it, and the container, it says that you run a Docker PS, and you see that's running, and you're like, wait a second, I'm not in it. I think I messed up. The command that you need now is docker attach, and you just specify the name of the container. So docker attach, compassionate Heisenberg, and I'm back to my CentOS container. Now, there's plenty of times when you want to start a container. We keep running bash, but there will be other containers that just will turn on and they'll start, like Apache, for example, or they'll start a database. And we want those to run in the background, but we don't want to interact with them. But yet we might want to still check in on them just to see if they're still running, doing okay, if they had any logs to write. So after we run a docker attach, we can disconnect from it and keep it running by running the escape command, which is kind of a cheat code. It's Control P Q. Because most of the time, if you're in a container and you press Control C, it's kind of a bad idea because that's going to the process that's running in the container, and it thinks you want to shut down. If it's a database, it's not going to go very well. All right. So when we ran that command, we still have our system running in the background. Now, we're done with it. We don't want to go into it to be able to press Control C on it. We want to just kill it. So there's two ways that you do it. Docker kill, the name of the container, which is very forceful and just will instantly stop it. The other one is Docker stop, which will give it a cool 10 seconds before it decides it's too long and then just kill it anyways. So you have those two options. All right, so now we're very happy with our first container. We've made a CentOS container running Apache, but we don't want to remember that container name. How do we make an image directly from it? Just going to be like we're doing source code updates with like Git, for example. So we're going to use docker commit, the name of the container, and then let's have everyone call it my first Apache. And then after that commits, it's going to give you a SHA-256 hash. And then we run the command docker images. And these are all the images that we now have registered with Docker Engine. We have the hello world that we started with, the two versions of CentOS if you're here in the room, but really they're the same one. And then my first Apache. So now we can start a new container running that, and it'll be configured exactly how we want it. All right. So let's try to execute again. But as soon as we go into it, I want it to execute Apache. So we're going to do docker, run it, my first Apache, httpd. Okay. So this isn't meant to really, really work, but I want to show a very easy step to fall into. So when you run a container that tells it to run a process, if that process will immediately go into the background, it tends to stop the container. So every time that we were inside of the CentOS container and we were running httpd, Apache was starting in the background mode, and then we could connect to it while the container was running. But in this case, we told it to go and run a new container. It just turned on Apache, went to the background, saw there was nothing on standard in, and just closed. So what we need to do is anytime we run a process, we need to make sure that it runs in the foreground. So we're going to run that same command, but we're going to give it the option of foreground. Everything to the right of this line right here is command arguments for what you're running inside the container. Everything to the left of this is command arguments that you're giving to Docker. So this D foreground is not a Docker thing. This is an Apache thing for just the purposes of this demo. Okay, so now that we immediately execute Apache, I don't have a prompt here that I can go back to. So we have to remember how to detach again. So anyone remember how to detach? PQ.
Control PQ.
All right, and then we do a Docker PS. And Apache's still running. All right, and just so now that we can't attach to it and run our curl command, how do we tell it to run curl while it's still doing something else right now? And the answer to that is Docker exec. So we don't want to secure shell into that container to manage it. We just want to tell it to execute a single command. So let's run Docker PS because we need to get the name of whatever container that we're running right now. So I'm called Epicurean, and I'm going to run Docker exec Epicurean, and then our little curl test command. Okay, so once again, we get a response back from a CentOS Apache server, and we now have a pretty, I would say, a stable website running in this container. And then we can go ahead and stop it. So at this point, we've probably made the most useless website container in the world because it only can serve on localhost. We're going to get to how to expose the port sections here in a second. So let's really quickly, since we're on the topic of images, let's talk about tagging images. So inside of Git source code repository, sometimes you have different forks of a process. Like you have your latest build of it, but maybe you make a branch of it, or you have a beta build. And Docker supports all that type of information when you're committing images. So when we ran Docker images, we see here that we have our repository and then our image name, and then here's the tag that says latest. When you don't specify it, it always assumes that your tag is latest. And you can commit something by specifying a tag with a quote. So let's say, or a colon. So let's say that we're going back to, what was that? Compassionate Heisenberg. And I want to tag this as my first Apache, but it's the beta build. So I ran my Docker commit. I put the little colon there. And then if I ran Docker images, I now have two versions of my first Apache. I have the beta build and I have the latest version. But let's say that I made a mistake and I didn't really want that to be a beta build. It's an alpha build. So I can rename it with Docker tag. And this really, maybe not rename, but copy the tag. So I'm going to copy my first Apache beta build to alpha build. And then I am going to remove my original tag. And because it's an image, I use Docker remove image, RMI. My first Apache beta build. It's been untagged. And now I am going to do Docker images. And I have my alpha build right here. Okay. So real quick, if we only want to keep this alpha build, I mean, we could kind of do that. But this is when we're going to get into the read and writable layers of Docker. Because we've run the My First Apache at least once, if we went to go and delete the My First Apache latest, it will tell us, hey, you can't get rid of that because part of that container is being used, or part of that image is being used in this container. And it asks you to force delete it. So we don't want to go ahead and remove that this time. But if you do try removing an image that's in use by some container that you've ran on that system, it's going to try to stop you right here. All right, so let's actually get into making our website at least a little bit useful. So the first thing we're going to do is port publishing. And what we're going to do is we're going to make a port on our host, map over to port 80 on our website. And that's going to be done with Docker run-p, P for port, which is how I always remember it. and they can be the same port, they can be different ports. We're going to map from 8000 to port 80. Docker run it, my first Apache, HTTPD, foreground. All right, and we got this thing now running in the background. All right, now let's check out that. Let's check out to make sure that website is running. Let's see, 64.131. I said 8,000. Okay. All right, so everyone's IP address will be a little bit different, but if all goes well, you should get this testing 123 page saying that your website is running on CentOS. And we can keep this container running because once again, we want to detach from it. So Control P and Control Q. And now we can refresh this. Our Apache image is still running at the time. All right. So, everyone good there? Good? Yeah? All right. Kyle's still good, so we're good.
Nobody's yelled at me yet. So
Okay.
We're still good.
All right, so let's move on to making a brand new container, and let's run it on a different port. Let's run 8001. And I want to show one other new command item to go along with our Docker run, because every time now we've been running it and then we've been detaching from it, well, we can immediately start a process and just tell it to immediately go into the background and make sure it still keeps running unlike before. D. I think it stands for detach, but I think of it as like daemon.
If you use screen, it uses D for detach.
D for detach, okay. So that's where it comes from. And so if we ran that same command as last time, only I've changed the port from 8000 to 8001, and now I run docker ps, I have two containers running, and it really handily tells me the port information. So 8001 is mapped to 80, 8000 is mapped to 80, and I go over here to my website, and I change this over to 8001. I now have a different CentOS site. All right. So this is kind of getting confusing because we keep on having containers being named randomly. As humorous as it is, let's actually pick a name for our next container. So let's go ahead and run this next one here, which is pretty much going to do the exact same thing we're doing, only it's going to call this Apache port 8002, and it's going to run on 8002. Docker ps, see all three of them are running. And you get the point. Now we have 3 Apache servers running. And let's do a quick break off of the plan here, and let's run a command called docker stats. Because I want to show how much resources each one of these are consuming at the current time. So this is like a top command that you have for each of your containers. And it tells us how many PIDs are running in each one of them, how much CPU usage. So each one of these that I'm running in a separate space, the first two are consuming 11 megabytes of memory and 9 megabytes of memory for the last one. So overall, very thin for each one of these could be running a completely separate website. All right, so let's go back and rename some of our old containers. And to rename them, very straightforward, is docker rename. So first we're going to do docker ps, and I see that I have Keen Ramen running on 8001 and Loving Wiles on 8000. So I'm going to do docker rename, Keen Ramen, Apache port 8001, and then I had okay. All right, so after I've completed my renames, now I run docker ps, and I have a friendly name for all of them over here on the right that I can reference a little bit easy. Going through our occasion here, we've already interacted with our websites. Anyone having issues interacting with any of their websites?
Good. All right. We're actually coming up to close to 8 o'clock, but we can keep this thing going as long as everyone's still willing to stick around. Yeah? Okay. All right, we'll keep on going then. All right, so let's go ahead and let's just shut off all of our containers. So there's a way that you can actually pipe Docker into Docker where you can tell it to shut off everything you need. So normally Docker stop needs a container name, or it needs this like unique hash value that's inserted at the top of it. So if you do a Docker PS Q for quiet, I think, quiet is how I remember it, you get just a list of those hash names on the left. And so with a little bit of bash, you can tell it to stop every single one that that command returns. So Docker stop, and then inside of parentheses, Docker PS-Q. Okay. All right. So we still can run Docker PS-A, and we now have made, I don't know, about 7 containers or so. And these are all still on my host. The little read-writable layer is the extra piece of disk space that they're consuming, but I don't need any of these. So there's 2 ways that we can completely clean house. So the newer way that's done is Docker container prune. And this will say, hey, it's going to remove all of your stop containers. Now, it's not going to get rid of any of your images, so our first Apache container will still be there. And I think this is kind of cool, because when you do this, it tells you that it reclaimed, amount of disk space. So, we've made that container a bunch of times, and it's still showing that we removed about 132 megabytes. So you have to keep in mind that that very first container that we made, that we installed Apache on, not only did we install Apache itself, but we had to go connect to the CentOS repositories and download information from there. We've had log files being generated by them. We've had different types of interactions going into the environment. So that's why it seems like we're deleting a little bit more than what we've actually been creating, if every Docker container is supposed to be really thin, but still much smaller than us deploying 3 CentOS boxes in VirtualBox or VMware. All right, there's another way that you can do this, and you'll find this in help guides before Docker Container Prune came out, is again using the scripting Docker RM, and you feed in all of your stop containers. All right, so we're going to start off with our first little lab. All right, I have a secret lab for you. It's running on port 1337. And you're going to start off by doing Docker pull, and this will come from the repositories. And we'll see it here in Docker images. And it's running a service on 1337. It is not a website. So how would you normally interact with some type of service that you don't interact with normally? So I want you to put together a Docker command using Docker run to run that container, which is PySecure Docker Lab 1. And you got to give it the right parameters to be able to connect to it on port 1337. So we'll take like a couple of minutes or so, and then we'll get into it. Okay. So connecting to it, I'll kind of cover that first, because I think that might be it might be slowing down some people. So Netcat is something that I usually use for interacting with a service real quick, just to see what might be on it. And so first, to get this set up, I'm going to run the container, and I need to expose or publish port 1337. And it doesn't matter what I'm really mapping it to on my host, but I'm just going to keep it really simple and just say 1337. I'm going to do the -D switch to make it run in the background, because I don't need to interact with it right now. In fact, if you ran it with the runit command, it probably just did nothing. Hopefully it didn't lock up your shell.
It does, because I tried to attach to it after I ran it to see if I could find it there too. And,
Nope.
yeah, it's stuck.
So you can't do that here. But when you run Docker PS, we still have it running, and the command that it's executing inside of it is start.sh. So when you make a container, you can actually specify what you want your default entry point to be in it. It's a term we're going to come to in a little bit. So that default entry point is the command that it's going to forcefully run unless you specify something else. So I'm going to do a netcat to localhost on 1337, and it is a ASCII animation video of the entire Star Wars A New Hope. So I didn't make this. This came out years ago, was hilarious, and I've watched the whole thing before. So my screen maybe is not too big, but anyways, and then I'm just going to break out of this, and I'm going to kill that container. So docker kill. Actually, when you press Control-C, it should stop. So what this was is this was actually just a shell script running a simple netcat relay. So when you connected to it, it did a netcat out to the website that hosts this 24/7 if you want to check it at any time. And it just returned that back to standard in. But the point of this was to get familiar with publishing the ports. All right, so let's move on to Docker volumes, because as of right now, all the work that we've been doing has just been thrown into the garbage because we just did a container prune. We still have our Apache image though. And something that, as an InfoSec person, I don't really think about like the content in the website running first. I think about the logs first. And so we're going to practice getting log files out of our Apache container and make sure that they're persistent on our host. So there's a couple of ways that you can move data in and out of containers in Docker. The major one that's easy to use is called a bind mount. And what it is it's a path that you pick on your host OS and a path that you map in the container, like a mount command. And anything that goes in and out of that path in the container will show up there on the host and vice versa. So this is a longer command, but let's break it down. The mount is specified with the -v switcher volume. We have the first section of the path leading here of where it's at on the host OS, and then we're going to move over into where we want it in the VM. So CentOS has this path right here as where it keeps its log files, and we're going to publish this on port 8002. So I'm just going to copy and paste this. Okay. So now if I go over to, if you were already in resource files, just go back out to the home section, and you should be in root. There's now a folder called logs. And when we go into that directory, we have an access and error log. And if we tail the access log, and then go to our website, instant logs. And we're not interacting inside of our container to do that. All right, and let's stop that, and we'll do docker stop Apache log redirection. That's what we name that container right there. Okay, so Docker volumes is the other way of doing this. Now, Docker volumes are, I guess, maybe considered the preferred way of doing it, but it's a little bit harder to work with because the idea is that it's going to start publishing that in almost the same type of file system as it does some of the images. And we'll first have to create the Docker volume, and that's done with docker create. So we're going to create a container, and it's going to be called Apache logs. And then we're going to create a new container that uses that. Now, this command is the exact same as last time with this -v switch, but instead of it specifying the actual mount path on our host OS, we're just giving it the container name. And this is going to be running on port 8001. Okay. And the cool thing about using Docker volumes is that it's way more resilient if you need multiple containers to write content to the same files. So for example, our 3 websites that we're running, we're all running Apache. We want all their logs in the same spot. And so what we can do is we can now run another one right here where we're going to tell it to do the exact same type of command, and it's going to keep all those logs together. I wanted to show, there's one other thing I snuck in here. With this, it's a --rm. What that does is when you run a container, normally after we stop the container, we can run a Docker PS and we still see it as stopped. When you specify the --rm, just when this container stops, just throw it away, which is really where we're going to, when you get familiar enough with running Docker containers, you could almost theoretically run every container with a --rm, because you've already designed your application to save all the information it needs and accept all the input it needs. All right, so let's get the use of those details of that volume. So we're going to use another container here to actually see those log files. So we're going to do the same thing here, and we're going to use a BusyBox, which is just a really small Linux container. And what I wanted to show here is we're going to take the Apache logs and we're going to mount it inside this container at /mount point. And inside of here, we have our access and our error logs, and we can do a follow of this with both of them. And if we moved over to our website on port 8002, we have logs. And if we flip over to 8001, we have logs. And then we can go ahead and stop this. And those containers are still running, and that volume is still accessible to us. Let's exit out of that.
But you have to access it through a Docker system? Like there's no way to interact with it through the native system?
You're 3 steps ahead.
Okay.
So let's show one other thing that's used with volumes. Is sometimes you don't remember all the volume names that you've created and mapped into a container, but you're just like, I want all those containers, all the volumes in that container, just give them to me. And they have a switch that's called volumes from. Now, when we made our very first container up here where we interacted with this volume, I gave it a name of VOL, Apache Log Redirect VOL. And we're going to do that same thing here. So we're going to run docker run volumes from Apache. I realized my example here is wrong here at the bottom. It CentOS dash. So now we're in a new CentOS container. And it's going to take all the volumes from that very first container that we ran. So if we go into, and it's going to map it wherever it's mapped in that other container. So this system that I just ran right here, of course this isn't running Apache, but it will have a var log HTTPD, because that's where it's being used here and in the container above it. So that way you can interact with your Docker volumes just by specifying a container. Now where this comes in really handy is where you need to back up a volume. So there's the preferred way of doing this is you just basically run a tar command. And this is one that we can run here really quick. But what it's going to do is it's going to pull out our container, load all the volumes from it, and then it's going to, oops, Docker is from no such container VOL. It should, if I specify that right, direct VOL. Okay. So it made us a backup.tar.gz. And if we do gunzip backup tar.gz, there's our Apache logs. So this is the preferred way of backing up a container. And it's, even though this is a relatively long command, it's easily scriptable, and you can enunciate it any way that you would like. Now, going over to your point about interacting it from the host, the nice thing about Docker volumes, though, is that no matter how many Docker hosts you have, those volumes can be transferred between them. But if you are on the host that has the volume at the time, you can actually get the full path by using the command docker inspect. There's a big warning sign on, let's see, docker inspect. It is Apache test. I'm sorry. So Docker volume inspect Apache logs. As you can tell, time goes on here. This gets a little less tested in the workbook, so we'll have to do some last minute updates to this. But we have the mount point here where it's on the host OS. And so if we actually went into this directory here, there's our error in access logs. So big warning from Docker, though, that you shouldn't interact with any of these volumes outside of a Docker process. I don't really know what happens. I assume if you put like a file lock on these, then maybe a container will crash. I did find that if I deleted these access logs and then tried to visit my website, my container just stopped writing logs. Apache doesn't go through and recreate it. If you make the volume inaccessible and then try running Apache again, Apache can't find its log folder and will not run. So it's really more specific to the application that you're running in the container than anything else. All right, and we'll go back to root. All right. Oh, that's why I can figure it out. That's the next step. Okay. All right. So we covered the restore volume into container. Now let's go over to the Docker Hub, which is really the best way of doing this. So I know we went through the process of installing CentOS and then putting Apache inside of it. That was really to show building a container with all your apps inside of it. But Docker Hub has a huge repository of applications already ready to go, running an individual application that you already need. And these are maintained by the projects themselves. So this is where we're going and finding the CentOS one. This is where we find ones for Ubuntu, Kali Linux. But this one right here is HTTPD itself. So this is a container that would automatically come down with an even smaller OS or footprint than CentOS, and it would only be designed for running one thing, and it's Apache. And we mentioned tags a little bit earlier. They use tagging to delineate the different numbering format or the versioning format. So if you need to run it with Alpine Linux as your underlying OS, or if you need 2437 or just 24, or you need an older version, you can use those different types of tags in there. So if you really think about any type of container that you might need, you want to set up an account here with the Docker Hub. So let's say that you were building a project using Nginx. All right, Nginx has an official repository right here, over 10 million pulls. Run docker pull Nginx, you now have an Nginx container on your system. And the list kind of goes on and on. So there is something we're going to, I believe, get to in just a second, where we talk about Docker files. So because we built our own container, we know exactly everything that's in it. We started with CentOS, which is a trusted container image, and we installed our first item into it. But this comes from CentOS. We're not using Jim Bob's CentOS, which could be found here on one of these other pages. Like this guy, this guy has a CentOS one with Smart Entry bundled into it. So you don't necessarily know what's in it, except for the Docker file. And this is like a little playbook, like a recipe, if you will. Some people use like chef recipes. This makes the container. So it starts with the real version of CentOS and then executes all its commands until at the very end of it is the Smart Entry CentOS. So when you're pulling from any image in Docker Hub, you want to make sure that A, it's from a trusted source, and if you don't trust that source, look at their Docker file. If they don't publish a Docker file, then you should be really suspicious. So for example, some of my containers right here, here's the Docker Lab 1 that you guys pulled. There's no Docker file right here, there's no description. So it's very common for coin miners to be inserted into these. Not that's what's happening on your system.
Let's see.
Sure, I'm not done. All right. And let's go ahead and head back to. All right, so let's go into another lab right here, and we're going to make our own internal CyberChef website. And the point of this is I want to have us make a CyberChef website where we're going to redirect in the CyberChef HTML site. So a couple of resources that you'll need to complete this is if we're going to be using this, if you want to use your Apache instance from earlier, you need to know where your website is actually at in that Apache instance. If you went over and you looked at this section right here, it says you should add your website content into var www.html. If you want to pull it from HTTPD or Nginx, it's going to be a different path. And when I say CyberChef, I really mean this command right here. So CyberChef, let me show you, if you've never used it before. CyberChef is this awesome, like, all-in-one tool for converting base64, hex, hex dump, but it's some website that somebody maintains. If you want your own internal version of it, you can download a copy of it right here, and that's what we're going to be doing with that wget command. All right, let's go ahead and get this kicked off. So, as the instructions lay here, first step is to make a directory called CyberChef, cd into CyberChef, and then go get CyberChef. And I'm going to scroll up to the command reference section that you might need.
I was just teaching somebody about CyberChef today. It's like my favorite thing. Like, you guys are like, yeah, but have you seen CyberChef? No? Oh my god, get over here. Stop what you're doing.
For a long time, I was using Burp, just for the encoder and stuff like that.
Make some cool recipes, save them for later. Don't eat them.
How's everyone doing on time? We're about 22 minutes after. Got about probably another 15 minutes worth of content to go through if all goes well.
Sure.
Okay.
I'm getting food after this, though. That's
Yeah.
hard. Yes. Food's getting.
Okay.
Yeah.
Jed's getting hungry? Yeah.
Two hungry people. Three hungry people.
So, I know you don't have a laptop. Is this helping at least?
Yeah, it's awesome. Really interesting.
All right.
And thanks to getting the batteries. Do you use this a lot in your work?
Mostly for all the reasons I had in the initial slide, where I don't have time to build a full install of something. I just want to run a command and then have that app work and then just shut it down.
So do you lean heavily on the hub?
Yes. So the hub, and then a lot of projects now on GitHub, they will include Docker files themselves. It actually helps with the application development process to just quickly prototype your application. Just build it in a new container, test it out, destroy it, make a change, do it again and again. That it makes it easy to build content off of that. Okay. All right. So I want to show one thing that I did trying to put the answer together here at the top. So if you have a container running that's already bound to a port and you try to run a new container, you'll get an error that looks like this, saying that a port's already allocated. So I'm going to shift this over to port 8003. And then I am going to go visit my website. And it's cyberchef.htm. All right, so while that loads, break down how the answer really works together. So from the help guide that we had here when we were visiting Apache, it said add your website content into var www.html. So I took my root cyberchef directory and I mounted it inside the container at var www.html. So the container sees one file in that folder, and it's called cyberchef.htm because that's the one we dropped with wget. And now we have our own container running of it right here. So this is moving a website into a container using a Docker volume. All right, any questions here? All right.
Super handy.
All right, Docker files. All right, so this is where it's really at. So we're going to build the container, and this is going to be a little less, I guess, workshop-y and just a little bit more descriptive here at the top. So I want to show the container that we built for that first lab. So it's actually that lab itself is in your VM. It's under your resource files. And actually, no, it's not under your VM. What was I thinking? Okay, it is on this VM. Nope, it's not under any of them. Prep fail. Oh no, it's lost forever. All right, cool. All right, so this started off as a series of commands. So the first one is from. This is the container that you're basing it off of, and this is the one from the Docker Hub. BusyBox is as I said, is a really lightweight one, and it's really common to use this when mapping volumes because we talked about that volume from option where you can just map everything and then reference a container name instead of having to remember every mount point. Well, people use BusyBox for that. Maintainer is a deprecated one, and really it's the word they're supposed to use as label. It's where you put your little from information that you would put in from get. The next one is add. So this container, when I was building it, had all of these files in it. It had relay and start.sh. So when you build the file, it's there in the current session, and it will add that to the container depending on where you specify it at. So relay or start.sh, make it add in the root sh and relay.sh. Run commands will run that command inside of your container as soon as it executes. So the first thing I'm going to do is chmod 755 and start.sh, and same for relay. And then my entry point is start.sh. So entry point is the command that we are running when you run the container by default. And you can still allow somebody to create commands or build commands beyond the entry point, but this will always execute right there in the beginning. So any other command would almost be an argument to this. Since we're running a little short on time, let me show you another little bit more advanced example. So let's go into this Docker malloc container. So this is going to be a Docker file to, not Docker compose, Docker file, to put together a malloc container. Malloc is used for parsing PCAPs. And so the first thing that we're going to do is it's based off of Ubuntu 18.04. I did update this for this lab here. We won't have time to really get to this though. And the first thing it's going to do is it's going to run apt-get update, and it's going to install all the packages that I need. It's very common when you run build Docker files that use these type of separators, like you're running it all on one line. And the reason for that is every line that you specify here is running inside of its own container. All right, so containers inside of containers to build containers. I know that sounds really confusing, even though I tried to make it sound that way. But this is a way that you can then go back and troubleshoot, because at any point in the build process, you can go back to any point and see what the container looked like at that time. So if you don't care if it's going to fail on an apt-get update, vice installing wget, curl, you can just combine that all together. The next section I want to go over is the run commands. So we're going to make a directory, and then we're going to cd into it, and then we're going to go and download a version of malloc. Add scripts to it with the add command, and then we're going to specify the run commands inside of it. So when you build a new application or you're putting together an install for it, you're running these commands yourself anyways. You're making your own files, you're installing Debian packages. So all you have to do is type the word run in front of it or add in front of it. You're really making a Docker file. Then the next part of it here is we're going to have it add all the different scripts to it. And then at the very end of it, we're going to have it set what the path variable needs to be inside the environment with an nv command, and then tell it where to change its directory to, the working directory, and then the entry point, what you want you to start. All right, let's show you how this actually works while it's building. So the command you use is docker build. You tag it with what you want to call the image. So we're going to call this one malloc v1. Then you can specify where you want the Docker file, where it should read it from. Because it's in my current directory, I'm just going to do dot. All right, so sending everything to the command. So it says step 1 of 36. So each one of those lines is a different command that's running. And right now it's finished pulling from the Ubuntu repository. Now it's running a whole series of apt-get commands. And we're going to just let this one cook in the background while we come back to it, because it has to go download 330 megabytes worth of stuff. So in the meantime, let's see if we can, actually, 8:30. I'd like to show you guys how to build the CyberChef container, but I think we're a little low on time. We got one other thing that we can do, and I'll leave this up to a vote in the room if we want to complete this or not. It's deploy Docker host in the cloud. So we've done some fun stuff here with just the VM, but what we can do is we can go through how you use Docker machine to be able to call a cloud provider. In this case, it would be DigitalOcean, and it'll build us a brand new Ubuntu server there, install Docker on it, and then accept commands, just like what we're doing right now with Docker, but it will execute in the cloud. We're going to build a VPN out there, and in that VPN, we're going to connect to it. You guys want to take the 15 minutes for that? Food? Food? Okay. All right. We might have to do a part 2 on this at some other time. So I guess with all that given said, any questions on anything I've covered so far? All right. Thank you all for coming and listening to me talk for 90 minutes. We can now go and get food. All right, thanks.